This video is on naming organic compounds or the nomenclature. So first step to name organic compounds, we must look for the longest continuous carbon chain. So if we have something like this, the longest carbon chain here would be 5. If we were to go the other way, it's still 5. Okay, but if we have a carbon chain that is something like this, so don't be mistaken that this is 5 is the longest carbon chain, because it's not. So we should go the other way, and therefore 6 is the longest carbon chain here. So that determines the first part, the first prefix of the naming. If there's 1 carbon, then meth. If there's 2, eth. 3, prop. 4, bute. 5, pent. And 6, hex. And so on. That's hept and oct and so on. Secondly, we will look at the link or bonding on the chain. Is it saturated or unsaturated? Okay, if it's all saturated, all single bonds, then it's an "an" to represent an alkane. Then if it's unsaturated, there's a double bond, we'll name it "ene." So that represents an alkene. But if it has a triple bond, so we'll put "ine" here, that represents alkyne. Okay, next part of the naming would be the functional group. So if it's an alkane, for example, with 3 carbons, so prop, so we put an "an" and E here. So it becomes a propane. Okay, if it has a double bond, so propene. If it have a double bond and an alcohol group, as in an OH, so propenol. So propenol. At this point, I'm just ignoring the numbering, so I'll tell you more about numbering later. So you need to put some numbers in between to indicate where are the double bonds or the functional groups. Okay, next rule, we need the lowest number for the functional group. So for example, this would mean that the alcohol, the all is at number 1. So if we count from the other side, 1, 2, and 3, then we would think the alcohol is at number 3. So we don't do that. Lowest number for the functional group. This is number 1. Okay, if there's the same substituent that occur more than once, then we'll have to put this prefix, di, tri, tetra. Okay, for example, if I have a CH3 here, so I'm going to draw the full structure this time, except this part is still a condensed structural formula. So this does not pass for a full or displayed structural formula, as I still put this in condensed form. Okay, so in this case, 1, 2 is having the CH3, and how do I name that CH3? So CH3 would be an alkyl group, so we're going to follow this way as well for the alkyl groups. So it could be a methyl, ethyl, propyl, so it goes the same way as our methane, ethane, propane, butane. So this would be a 2-methyl, and 1, 2, 3, 4, 5 pentane, because it's all single bonds, so I know that it's saturated. Okay, so what if it occurs more than once? So number 2, there's the methyl, so 2. And number 2 has the other methyl, so 2. And number 3 has 1 more methyl, so 3. And total, there's 1, 2, and 3 methyl groups, so tri-methyl pentane. So this is how we name this. So 2, 2, 3, we have to specify exactly where are the methyl groups. Next rule, if there's two or more different substituents, like this, there's a bromo and a chloro here. So we go by alphabetical order, not by the carbon number or the position in the group. In this case, B comes before C. So we have to name the bromo first, then the chloro. So 1, 2, 3, 4. So 2 bromo, 1, that's the chloro there. So this must be alphabetical order. And then butane. So same goes, if I have something like triethyl compared to a dimethyl. So although we see T and D here, we don't count this. We look at the ethyl and the methyl. So ethyl still comes first. So triethyl comes first before dimethyl. Same story here, another example. So tribromo comes before dichloro because B comes before C. Let's go through some examples. So the longest chain here it is. There's 5 carbons here. So if I were to count from the top, 1, 2, 3, third one is having the methyl, or if I count from the right here, 1, 2, 3 is also having the methyl, so it makes no difference. So 3 methyl pentane. Okay, the next one. So the red carbons here are the main chain. If we were to go to the other direction, that works as well. So it gives us the same thing, there's 6 carbons anyway. So where to count from? So I'd count from the right side so that the methyl is on a lower number. So if I count from the left side, the methyl will be on number 5. So I want the substituent to be on a lower number. So number 2 is having the methyl, 2-methyl hex, and it's all single bonds, so ane. The next one, so this is the longest chain. If I were to count from the top, 1, 2, 3 has a substituent, 4 has another substituent, 5, 6. If I were to count from the other side, from the left side, 1, 2, 3 is having a methyl and 4 is having the methyl as well. So it makes no difference whether I count from the top or from the left. So either way, number 3 and number 4 is having the methyl group. So 3, 4 dash, there's 2 of this. So dimethyl and 1, 2, 3, 4, 5, 6 hexane. And the last example here is what we discussed earlier. So 1, 2, 3, 4, 5, 6. We don't go by numbering, we go by alphabetical order. So bromo should come first. So 3 bromo. Number 2 has chloro, and it's a hex again, hexane. So that's how we name them. There are more functional groups which you should know the names. So for example, if you have alkane, so the ending would be ane, alkene, ene, alkyne, ine. Halogens, we have the halo, so chloro, bromo, fluoro, and so on. Alcohol will end with all. So if there's an alcohol somewhere here, then we put the number and put an all there. I'll show you that in a while. Ether, so it goes by oxy and ane. Aldehyde ends with an al. Ketones end with an ome. Carboxylic acids end with oic acid. Esters, in the middle, we'll have an il, and the ending has an oate. Okay, we'll just cover till that for now. So if I have a carboxylic acid, something like this, So there's 4 carbons here, and I'm gonna put a bromo here. So in this case, I've got to put the functional group at the lowest number. So this is the main functional group here. So 1, 2, 3, 4. So it's 3 bromo. Bute. Are they all single bonds? Yes, they're all saturated here. So single, 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 all the way single here. So butane. And remember, for carboxylic acids, we use oic acid. Butanoic acid. Let's look at this example for alcohols. So I'll count starting from the right side because that gives the alcohol, the OH, a smaller number. So it's a bute. So butane. Of course, you got to make sure that all are single bonds. Otherwise, it's going to be butene. So butane number 1. Oh, and if I switch the position of the OH, it's going to be butane 2-ol. There is no butane 3-ol because then that would become number 2. So there's no such thing as butane 3-ol. What about the next one? So I can count from either side. 1, 2, 3, 4. So 2 and 3 will have the OH either way. So butane 2, 3, and there's 2 of it. So di. All. That's how you name that.